Hey everybody, we're at 9.1, factoring by grouping. So our last unit, or our last lesson, I guess I should say, we learned how to find two things that multiply and add. We won't be using that for 9.1, but we're going to learn about factoring by grouping, and then we're going to combine our first lesson and this lesson to learn how to factor trinomials, quadratic trinomials. So think about these kind of like individually for now, but we will learn how to bring them together and make something amazing. All right, so there's a few examples for distributing. So if you want to give that a try, distribute a bit. I'll probably skip that, but I think it's a good idea for you to practice with that. And then we also learned, this was our last unit, we learned how to factor. And this is still going to be very important. So I'm going to go a couple of these, do a couple of these. Pause and give it a try if you would. Make sure you haven't forgotten how to do these things, okay? So again, for taking out the greatest common factor, it can be a leading negative, it could be a number, or it could be a variable. So here's an example where all we can take out is a number. We can take out a 2, but then we need to write down what's left. So we need to divide both of those terms by 2, and that leaves us with x squared minus 2. All right. Here's another example. What's the greatest common factor? It looks like we could take out a b. Again, when we're looking at the variables, it's always going to be the smallest exponent. Okay, so we can take a b from all of those. So if we do that, we need to divide everything by b. And that would leave us with 3b squared plus 2b minus 4. Okay. Okay, here's the last one we'll go over is we need to look at this and say, well, we have a leading negative. So we have a negative. We look at these 3 coefficients. What can we divide all of them by? Looks like it's a 2. And then we look at the smallest exponent. That means we can take 3 x's, or x to the third. Okay, and then we need to write down what's left. So we divide everything by a negative 2x to the third. Right? So here we'll do like the numbers first. So negative 6 divided by negative 2 gives us a positive 3. And then we subtract their exponents, so that gives us x squared. Or we can think of it as we have 5 x's and we're going to take away 3. Okay? And then we'll divide our coefficients, so that gives us a negative 1. And then we have 4 x's, but we're going to take away 3. That leaves us with 1x. And then we'll divide our coefficients. That gives us a positive 5. And if we have 3 x's and we take away 3, then there's none left. Okay? So we learned how to do that, taking out the greatest common factor. Now, what if we have a problem that's like this? What's the greatest common factor? Well, if we look at the sign, there's not a leading negative, so we can't take that out. If we look at the 4 coefficients, the only thing that could divide all of those by is 1, and that's not super fun. It doesn't really do anything. What's left behind is still the same as what it was when we started. Okay, and then we could look at the variables. Well, here's our smallest exponent, but we have a constant, which means we can't take any x's out of that term. All right, so again, this would be kind of like an x to the 0. This would be an x to the 1. So that means we could take 0 x's from every term. Okay, so it looks like we're at an impasse and we can't simplify this, or factor, we can't factor it out any further. But we're going to learn something a little different which is called factoring by grouping. Okay? If you have 4 terms, this is a really good way to factor. In effect, let's look at a problem. Well, let's do it over here. Let's look at an example that we've done before. If we had a problem that was like x plus 2 times x plus 3, okay, what we did is we did foiling, or we did a box method. So we did the FOIL would give us an x squared, and that would give us a positive 3x. That would give us a positive 2x, and this would give us a positive 6. So if you notice, when we distribute a binomial, 2 binomials, multiply them together, we end up getting 4 terms. Nothing, very similar to what we just tried up here, but we couldn't get it to work. All right? So the plan today is we're going to start with an expression that has 4 terms, and we're going to go the opposite direction. So when we're done, we should end up having 2 parentheses with x's and numbers inside. Okay? Another way that we distribute was using a box method. So since this is a binomial times by a binomial, we did a 2 by 2, and we did something like x plus 2 and an x plus 3. And we would multiply, like x times x is x squared, x times 2 is 2x, and 3 times x is 3x, and 3 times 2 is 6. So this is all multiplication. So this is just a quick review, all right? And then what we did is we combined like terms, but really this is x squared plus 2x plus 3x plus 6, and we would combine like terms. Right? So again, if you use the box method, you still end up getting 4 terms. So there are 2 ways to factor by grouping, and I will go over both of those. You can choose which one you want to do. I started just only doing like the one way, and then in class I did it the other way because some people like it better. Okay? So if I give you this 4 terms and we want to do the box method, well, we would just replace these back in. So if that makes any sense, let's do this in an example. So say we had a problem that's similar to that, where we have 4 terms. When we were distributing, we took out these and we combined like terms. Okay? But here we're going to do the opposite. What we'll do is we'll take those 4 terms and now we'll put them into our box. So we'll do 4x squared, and then we'll do 20x, and then we'll do negative 3xy, and then we'll do the negative 15y. Okay? So just like here, we took our first term and put it in here. It's the same thing that we just did, except we're doing it backwards. Okay? All right? And when we did the box method here, what we did is we multiplied, let me do a different color. We multiplied these things together to find what goes inside those boxes. Okay? But we're going to do the opposite of multiplication. We're going to divide. Okay? Or in other words, we're going to factor out the greatest common factor. So we'll look at these 2 terms, and we want to see what is the greatest common factor. And it looks like, if we look at the numbers, we could factor out a 4. And then for the variables, it looks like we could take out an x. And again, it's always going to be your smallest exponent. So we can take out a 4x. And we're going to do this for the second row. What's the greatest common factor for those 2 terms? What can we divide? Well, let's first say we have a leading negative, so we should write down our leading negative. And then we'll look at the numbers. What can we divide 3 and 15 by? Evenly. Well, 3 is, so we could factor out a 3. Can we take out an x? Nope, because there's not an x in the second term. But there is a y in both terms, so that means we could factor out a y. All right? All right, now let's do the columns. So like when we did grouping, is we would put those two parentheses on the side and on the top. Okay, so we also need to find the parenthesis that needs to go on the top. So what we'll do is we will look, we need to find the greatest common factor for the first column. So what can go into 4 and 3? Just 1. So we could put a 1 if we want to. And then if we look at our x's, we have an x squared and an x. So the smallest exponent would be an x to the 1, or just x, so we can take out an x. Now we'll do it for, let's see, I need a different color, for the second column. So if we look at the numbers 20 and negative 15, or I guess just the 20 and the 15, what we can divide all of those by is 5. And we can't take out an x because there's not an x in the second example. And we can't take out a y because there's no y in the top term. Okay? So now we have our two parentheses. Okay, one is what's on the side, so 4x minus 3y. And in our other parenthesis, we have 1x plus 5. Right? So one thing that we should always check when we do these, if I can do this, is just like when we did the box method to distribute, we multiplied like the x and the x gave us the x squared. We can always check and make sure we got it right by multiplying. So 4x times 1x gives us 4x squared. Okay, and then we'll try 4x times 5. Well, that should give us 20x. It does. Then we'll do the negative 3y times x. That gives us the negative 3xy. And then we'll do the negative 3y times 5. And that gives us the negative 15y. So we should always check that, or we can check that to make sure that we did it right. Okay? Let me just clear that out a bit to make it a little less complicated. Okay? So as anything, these things take some practice, and once you get it, it's going to go a lot faster. Okay? So this is using the reverse box method. Okay, so again, what we did is since we had 4 terms, we could just put all of those in our box. And then we would factor out the greatest common factor from each row and each column. And that turns out to be what's on the side is one of our parentheses, and the top is another one of our other parenthesis. Again, you could redistribute all of those, your answer, and you should get your original problem. Okay, so let's do another example. Okay, over here it says, what should you look for first when you factor? And you should always check for the greatest common factor. It's going to make a difference for either of the ways I'm going to teach you how to do it. Okay, so I put a little star on B because this has a greatest common factor. What could we divide all of these by? Well, we could divide all of them by 3. So the greatest common factor here is 3. And when we're all done, we should have that 3 at the end. So we should have some sort of 3 and then 2 parentheses. All of our answers are going to have 2 parentheses. So we can kind of save that so we don't forget. Oftentimes people forget. Okay? All right, so once we simplify that, we'll end up getting what? let's see, we'll get x to the third minus 2x squared plus 5x and minus 10. So we'll take all of those and we'll put them into our box. Our x squared minus 2x, or sorry, that's an x to the third, and our x squared, and then a 5x and a negative 10. So always put them in just like you're reading a book. Left to right, top to bottom. Okay, now we need to look and see what the greatest common factors are for the rows and columns. So if we look at our first row, it looks like for the numbers we could only take out would be like a 1. And typically we don't need to write that out because we can take out 2 x's. So again, we always look for the smallest exponent. So we can take out an x squared. For the second row, if we look at these two, what is the greatest common factor? So for the numbers, we can take out a 5. We can divide all of those by 5. And then for the x's, we can't take out any x's because there's no x's in the second term. Okay? All right, so that's one of our parentheses is going to be x squared plus 5. And then we need to look at the other. So we'll do the greatest common factor for the first column. It looks like we could take an x from both of those. And then for this column, we can take out a negative 2. Okay? Can't take out a variable because there's not an x in the bottom term. So then we could write our other equation as x minus 2. Again, we can always check by multiplying. So x squared times x gives you x to the third. X squared times negative 2 gives us a negative 2x squared. 3 times x gives you, 5 times x is 5x. And then 5 times negative 2 gives you a negative 10. Okay? And we can make sure we got that. Okay? And that's it. All right, let's talk about the other way to do this without using the box method. So I'll just get rid of that, and I'll show you the other way. Okay, some teachers teach it this way. If you're doing this secondary math 2 junior senior, Miss Summers does it this way. Okay. All right, so here we go. What we do is we cut it in half. Basically, we're grouping it. We're making 2 groups. A group of the left side and a group of the other side, the right side. So you do the same sort of thing that we just did. We look and see what's the greatest common factor for the left side. So if we look at these, for the numbers, it looks like we could take out a 4. And for the variables, we can take out an x squared, because that's the smallest exponent. Then we need to write down what's left behind. So we'll divide everything by 4x squared. The 4's would cancel. If we had 3 and we take away 2, that leaves us with 1. And 8 divided by 4 is 2. And if we have 2 x's and we take away 2, then there's none left. So they just cancel out. Now we'll do the right side. What's the greatest common factor? And we always need to take something out. So we can't take out any x's because there's no x's in the last term. So we'll just take out a 1, and we'll do a positive 1. Okay? All right, and then what's left, if we divide everything by 1, would give us the x plus 2. Okay, nice thing about grouping 2 is that when you have these 2 parentheses, they've got to be the same. If they're not the same, then you made a mistake, and you need to go back and see what the mistake was. All right? So just like we've noticed before, like here we could take out an x squared because there were 2 x's in both terms. Now we have an x plus 2 in both of these terms. So this is like term 1 and this is term 2. Okay, we can take out an x plus 2 from both of those. So we would take that out in the front. and then what's left is what's in front of those parentheses. So we'll have a 4x squared plus 1. So that is the other way of grouping. Okay, so whichever you prefer, just make sure you stay with it. I'll do another example of, actually, why don't we do this one with grouping, okay, with cutting it in half. All right, so if you're okay doing the box method, then you can probably skip this part or do this. You'll get the same answer. So if I'm going to do, if I cut it in half and do grouping in that way, then, and you want to do the box method, it's okay, we'll get the same answer, okay? So we just look and say, well, what's the greatest common factor? But wait, Mr. Warner, there is a greatest common factor that we should do first. So if we look at 8, 6, 24, and 18, it looks like we could divide everything by 2. So we'll divide everything by 2. So what's left would give us 4x to the third plus 3x squared minus 12x minus 9. So we still need to do that no matter what method you do. We need to take out that 2. So I'm going to write over here 2. I'm going to make my 2 parentheses so I don't forget that I took out that 2. All right, so then we'll do grouping. We'll cut it in half. Greatest common factor for the left side. For the numbers, we can't take out anything except for a 1, but we can take out an x squared because that's the smallest exponent. So we'll take out an x squared. We need to write down what's left. Okay, so if we have 3 and we take away 2, we'll have 1x left, and then we have plus 3, and then we have 2 x's we take off, so there's none left. And on the right side, the greatest common factor, it looks like we could take out a negative 3. Okay, again, if we have a leading negative, we should take care of that. So we'll divide everything by a negative 3, and that leaves us with what? Positive 4x plus 3. As you notice, these are the same, and they gotta be, okay? And like that, we could also factor those out in the front because we have 4x plus 3 on both terms, so we can take those out, and what's left is our x squared minus 3. So this goes like here. Okay. I will do these 2 more. If you're good, you're good, and you don't need to watch this. I'm going to do one more with the box method and one more with the regular grouping, okay, with cutting it in half. All right, so here we're going to do our box method. There's no greatest common factor, so we can go straight to putting those in the box. So 3xy minus 21, and pause and give this a try if you're going to do this. Okay. So look at the greatest common factor for each column and row. So for the first row, looks like we can divide everything by a 3, and we can take out a y. For the second row, looks like we could divide everything by 5. Can't take out any variables. For our first column, it looks like we could take out an x, so maybe I'll use a different color this time. So we can take out an x from both of these. And then here, if we look at these are bigger numbers, but what could we divide 21 and 35 by? And we also have a leading negative, so we'll do a negative 7. And we can't take out the y because there's no y in this term. All right, so now we have our 2 parentheses, 3y plus 5 times x minus 7. Bam. Okay, and we'll do grouping one again. So we'll cut it in half. There's no greatest common factor in this case. So we will say, what's the greatest common factor for the left side? it looks like we could take out an x squared. Okay, that will just cancel, and all we'll have would be y minus 3. And on the right side, for the numbers, it looks like we could divide everything by a negative 8. Okay, again, if we have a leading negative, we'll need to make sure we take that out. So we'll divide everything by a negative 8, and we get a positive y minus 3. Okay, we know we got it right because the two parentheses are the same. We can factor those out to the front, and then we'll write down what's left behind. So we have a x squared and a minus 8. All right, so that's about everything. On your homework, I told everyone that you didn't need to do 13 and 15, so that's extra credit. I also wanted to circle the ones that have greatest common factor. I want you to at least are able to identify it maybe next time. So I'm going to tell you that they have a greatest common factor. It's 3, 6, 9, 12, and 16. Those all have greatest common factors. And I guess 15 is as well, if you want to get the extra credit. All right. We'll talk to you later.